Hey everybody, we're just going to complicate things one itty bit more today. Not a big change today. I just wanted to point out that sometimes sinusoids will have a negative in the front of them as opposed to a positive. And I just wanted us to talk about what that would mean. So if you think about it, if the negative is out front, it's outside the function. It's not like inside the function, it's outside the function. So it's going to do something to y. And what you might remember from earlier this year is if you multiply by a negative outside the function, it actually takes your whole graph and flips it upside down. So all your positive y's become negative, all your negative y's flip positive. So what I'm going to do is, we know what a typical sine cycle looks like and what a typical cosine cycle looks like, and I'm going to have us draw them flipped upside down. So this is the graph of positive sine x. If you wanted a graph of negative sine x, the graph is going to look almost identical. It's just going to flip. So instead of starting at equilibrium and heading up, this graph is going to start at equilibrium and head down. So like what was this high point at 1 has now flipped to a low point at -1. And then it's going to come back to equilibrium, go up to a maximum, go back to equilibrium, still finishing a period in 2 pi. The only difference is that for negative sine, you start at equilibrium and you go down. Okay. And you guys can probably predict what would happen if I tried to graph negative cosine. Again, if I try to graph negative cosine, the graph is going to look identical. It is just going to be flipped upside down. So instead of starting way up here at a maximum of 1, it's going to start at a minimum of -1. And then it's going to go up to equilibrium, up to a maximum, down to equilibrium, down to a minimum. Still finishing its full cycle in 2 pi. The difference between positive cos and negative cos is just that this starts at the min. So here's the deal. Moving forward, you're going to be most successful with sinusoids if you have these 4 different patterns memorized. You want to know that positive sine starts at equilibrium and goes up, negative sine starts at equilibrium and goes down, cos starts at a max, and negative cos starts at a min. If you can remember all of that, you're going to be ready to graph any sinusoid I give you, no matter what the amplitude, equilibrium, and period are. So we're going to do a couple examples with that. You'll see that these examples look really, really similar to the ones you did last time. The only difference is that some of these are going to have a negative in front, which means we want to look at these negative cycles. So for our first example, suppose that I asked you to graph the function y equals -4 times the sine of pi over 6 times x plus 10. Okay, so let's identify the properties of this graph. This is exactly the same as it was last time. I can look at the vertical shift outside the function for how much the graph's middle moved up or down. So this is going to be the equilibrium. I know my graph has an equilibrium at the line y equals 10. So if I'm sketching a graph of this here, I know that I can start by saying, all right, this is my x-axis, this is my y-axis. My equilibrium line is at y equals 10. Okay? And then the amplitude of this graph is always the vertical stretch, because amplitude is how far you stretch from the middle. You can completely ignore the negative for now. The amplitude of this graph is 4, meaning I can go 4 above equilibrium to get to my max and 4 below equilibrium to get to my min. So 4 above would be 14, 4 below would be 6. Okay, and then for this equation, the b value is pi over 6. And I know that the period will be 2 pi divided by the b value. So my period is going to end up being 2 pi times the reciprocal of what's in there, 6 over pi. The b value here is going to be, the b value is pi over 6. The period is going to be 12. Meaning that at an x value of 12, I have finished up a full cycle. All right, so you might remember I made a point on the last video that you're not just interested in the period, you're interested in the quarter period, 1/4 of the period, or the period divided by 4. If I divide this by 4, I'm going to get 3. So that means I'm going to have a special point at 3 6, 9, 12. So basically, I've set up the boundaries for my graph, and the fact that it's a negative 4 times the sine means all those properties are what I would have expected last time. It's just that instead of having a positive sine cycle, I'm going to have a negative sine cycle. Instead of starting at equilibrium and heading up, I'm going to start at equilibrium and head down. So, because it is negative 4 times the sine of blah, 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 I'm going to start at equilibrium and head down to my minimum, back up to equilibrium, up to my maximum, back to equilibrium, and I will have closed out the cycle. So, it's a whole lot of stuff, but you'll notice the only new thing today is that because there is a negative in the front, I started at equilibrium and I headed down. Cool. Okay, so we're going to continue to work with this. I'm going to erase this beautiful graph. Why don't we do one where we go the other way? So I'm going to draw a graph for us, and then we'll see if we can figure out its equation. So let's imagine that we saw a graph that looked like this. So I'll draw my x-axis and my y-axis. And let's imagine we saw a graph that had this as its basic shape. And I'm going to give you a little bit of information about sort of where certain stuff is on that graph. Let's say that the minimum line is at 12, and let's say the maximum line is at 30. And obviously, if this is a sinusoid, it's going to repeat itself over and over and over again, because sinusoids keep going and going. That's the nature of a sinusoidal function. But I'm going to say that the close of this first period, when I go from a minimum all the way through a full cycle and I get back to another minimum, let's say that the close of that period is, how about 24 pi? Okay, so if I wanted to find the equation of this graph, much of it is the same as it's typically been. I know my maximum and my minimum, so I know that the equilibrium is at the average of those two things. So I'm going to average 30 and 12. 30 plus 12, when divided by 2, becomes 42 over 2. The average line for this is 21, which makes a lot of sense when you think about how far that is from the top and the bottom. 21 is 9 below 30, and 12 plus 9 makes 21. So I feel pretty clear that the equilibrium is at y equals 21, and the amplitude, how far I stretch away from that, is 9. Okay, then I see that a full period for this graph is 24 pi, and I know the b value is going to be 2 pi divided by the period. So the b value is going to be 2 pi divided by 24 pi. The pi's will cancel, and so this is just going to turn into the fraction 2 over 24, which simplifies to be 1 over 12. If you think about that for a second, the fact that I'm going to have 1/12 inside the function is why the period is 12 times as long as it usually is. Okay, so putting all of this stuff together, when I go to write the equation here, when I think about, is this a sine wave or a cosine wave, what I notice is that the cycle starts at its minimum, and then it heads on up. That tells me that instead of being a typical cosine wave, this is a negative cosine wave. It started at the bottom. So the only thing I have to do is when I write my equation, in front of the amplitude, I'm going to have a negative sign. The negative is why the cosine is flipped upside down. So this is going to be negative 9 times the cosine of my b value, the thing that goes inside the function, is 1/12 of x, and then I have an equilibrium line of plus 21. And so this zany equation, negative 9 times the cosine of 1/12 of x plus 21, will look exactly like that graph. You've got the same properties we saw last time, equilibrium, amplitude, and a b value that tells you the period. And the fact that it starts at a minimum is why it's negative cosine instead of positive cosine. Okay, we'll do one more. All right, so for our last one together, let's say that I gave you a graph that looked like this. Ooh, that was a good squeak, huh? Little x-axis, little y-axis. And let's say that our graph went down, and then it went back up, and then it went down, and then it went back up, and it keeps going and going and going. But I'm going to say that we've got some clear information about this graph. Let's say that the minimum output is -10, and let's say the maximum output is -2. And then I'm going to do something a little weird. Instead of telling you where you have a full period of this graph, I'm actually just going to tell you that this point right here, let's say that that has an x value of 5. Okay, so can we figure out equilibrium, amplitude, and period? For sure. So the equilibrium is always the average of the maximum and the minimum. So in this case, I want a number that's halfway between -10 and -2. If I add those together, I get -12. -12 divided by 2 tells me my equilibrium line is at -6. So I'm going to label this as -6. And if I check, that should be the same distance away from the top and the bottom. It is indeed 4 above the bottom, 4 below the top. So I know my amplitude for this graph is 4. In terms of the period, that's a little weird for this graph because I didn't actually tell you the full period. What did I tell you? Well, I told you how long it took to get from equilibrium down to the minimum. I told you basically about 1/4 of the cycle. So instead of giving you the period, I gave you 1/4 of the period, how long it took to basically sort of make one special journey. So if this is 5, this has to be 10, this has to be 15. It must be the case that I'm closing out the period at 20, right? You close the period whenever you have a full cycle, whenever the graph starts to repeat itself. So this right here, equilibrium to the bottom, back to equilibrium to the top to close out equilibrium, that's a full period of 20. And so we know that the b value, the thing that goes inside the equation, is 2 pi divided by the period. In this case, 2 over 20 makes 1/10. Our b value is pi over 10. And if I put this all together to make an equation for this graph, I know that I am looking at a negative sine cycle. I knew that because this graph started at equilibrium and it headed down. So this is going to have an equation of negative out front because it's a negative sine cycle. -4 times the sine of pi over 10 times x, and then that vertical shift of equilibrium is going to be a little -6 at the end. The graph has a vertical shift of -6. That's what moved the whole middle of the graph down to -6. It has a vertical stretch of 4. That's why the graph stretches 4 away from the middle. The fact that there's a negative means the whole graph flipped upside down, so it's going from equilibrium downwards. And then the pi over 10 came from the fact that the period was 20. So for your homework, you're going to be working on a bunch of problems where you put all of this together. And you're going to do great, my rabbits. Great. Have a lovely day.